Hi all. This video recording is to give a walkthrough of vectors and why we use vectors. So, firstly, throughout CS 135, you might have extensively worked with arrays, but the drawback of arrays is that, like whenever we compile the program, like whenever we do g++ main.cpp or whatever the program it is, whenever we compile this, at this time itself, we have to tell that, let's say if I'm creating an array of integers. Oh, just a second. Yeah. At this time itself, we have to tell how many elements are going to be there in the array. So that's the drawback of arrays. Like, why is it a drawback of arrays? I'll talk about it. Like, let's say you don't know how many elements that you're reading from a file into an array. So just to be sure that you are taking a lot of space and ensuring that your array fits in all the data that's in a file. Let's say that we are declaring an array of integers called AR, and I went ahead and I said, like, I want an array with 1,000 elements. And the point here is that for one integer, we need 4 bytes of space. Now, for one integer, if we need 4 bytes, for an array containing 1,000 integers, I would be needing 4,000 bytes of space. And this space, we are talking in RAM of the computer. Okay. And this RAM is costly. So that's why there is limited RAM in most of our computers compared to hard disk or secondary storage. Generally, RAM would be like 4 gigabytes to 64 nowadays. It's being common, 32 or 64 gigabytes like that. So that would be the size of RAM. It's limited, it's costly, it's fast. So that's importance of RAM or in one way. Now, the thing is, out of an important storage area, if we are asking for 4,000 bytes and from a file, let's say input1.txt, if I end up reading only 5 values, so I'm only reading 5 values. This is my huge array, but I'm only reading 5 values. And rest all completely wasted. So if you see, the problem is that we only used 5 blocks in the array. So 5 times 4, we ended up using only 20 bytes. So that means out of 4,000 bytes, I only utilized 20 bytes. That means I'm wasting a lot of memory by creating an array. So again, the first reason why I created an array of bigger size, because when we are compiling a program, C++ expects us to tell the size of array at that point itself so that it will go and reserve memory in RAM. So that for that memory reservation and stuff, we have to tell at the beginning or at the time of compilation. So now at this point, we have an alternative called vectors. And the advantage of vectors is that things happen at runtime, unlike arrays, which happen at compile time. Now things change when it comes to vectors. Runtime means when you are running a program by using one of these commands. So when your program is actually running inside the computer, you can allocate, remove, shrink, do a lot of stuff with vectors. But here, when your program is running, when it comes to arrays, you cannot allocate new space. we cannot remove space. So the term I'm using for this removing is deallocation. So we cannot ask for memory, nor we can give up memory with arrays. So no allocation and no deallocation. So that's the deal with arrays. But with vectors, we can do both. We can allocate and we can deallocate. So we can do both with vectors at runtime. So we can allocate, we can deallocate. And if you can do both at runtime, then we call it as dynamic. So, and we like dynamic things because we can control memory. Like if I want new space, I can ask for it. If I'm not using excess space, I can remove or I can deallocate it. So that's how we prefer dynamic things. And all at the root cause of this is that RAM is very costly and we need things to be in RAM when our programs are executing. So to save space with RAM, we take advantage of vectors in C++. Now, bearing this one are similar, rest all of things are similar. Now, let's see how vectors work in C++ real quick. And yeah, so yeah. So like arrays, you can also declare vectors in the similar format. And for working with vectors, you need an extra library called vector. So we go ahead and whenever we write a program that involves vectors, we simply do hash include vector. And for creating a vector, um, we will start with vector keyword, and then we will use these angular brackets. Within these angular brackets, you get to specify the data type of vector. For example, if I want to create a vector of integers, and let me call it vec, I can simply do it in this manner. And the beauty of vectors is that I don't need to say the size. It could be empty vector at the beginning, no space, nothing. So that's the beauty of vectors. But for arrays, if you see int, whatever the name, and I have to specify the size. So that's the deal. So now coming back to vectors, you can initialize them in multiple ways. So first thing, when creating a vector, we can ask or create an empty vector. So create an empty vector, or we can also ask create a vector with, let's say, 10 elements. So vector, I want float. So this time this vector is going to contain all float values. And all I would be doing is give the name for the vector. And within parentheses, here in arrays, we use square brackets. But for creating vector with n number of elements, we use circular brackets or parentheses followed by a semicolon. You can tell that, for vector 2, you're asking for 10 elements. And remember, the concept of garbage values in arrays. When you have asked for a memory, a block of memory, like in this case, I'm asking for 10 elements inside the RAM of float. So float is 4 bytes, 10 times 4, 40 bytes I'm asking in RAM. Then it's going to be garbage values at the beginning. And it's my responsibility to ensure that I have some valid values and not garbage values. So, and another thing, whenever we worked with arrays, we used for loop extensively. So for loop and vectors, they are used together. So now that I know that how many elements are there in vector, I can go ahead and write loops to control that. And another interesting thing is that we can ask for more space on vector. We can remove existing space on vector. So to deal with these sort of things, like the dynamic things, vectors have some sort of capability. And that capability is that vector methods or vector functions. So vector methods, the first vector method is size. At any given point of time, if you want to know how many elements are there in a vector, you can simply use vector.size. For example, I have created integer vector here, but I have not said how many elements I want. So if I go ahead and say vec.size, So this is going to give me the size of the vector at this point. So I'll go ahead and run it. You can see that I asked for an empty vector. I'm not adding any elements, so it's going to be 0. So at any given point of time, if you want to know the size or the number of elements in a vectors come up with a method called size and simply take advantage of size. In the case of vector 2, I explicitly asked for 10 elements, so the size is going to show as 10. So that's the first function. Vectors come with a function called size, like how we have string dot size. Vectors do have size. So that's how it is. And another thing, let's see the other vector methods. Another thing is that um, when it comes to vectors, we generally talk about pushback and popback, two methods. So in computer science, from here on, the moment you hear the term push, this means that you are inserting or adding an element to a vector. Okay, so you're inserting or adding an element to the vector. Let's say I created a vector 2 with 10 elements. Okay, this is how I created vector 2. So vector of float, I created a vector with 10 elements. So imagine that 10 blocks of space is given for you or for this vector in RAM, and indexing starts at 0, 9. Now, so before going into pushback and popback, let me write a for loop. I'm writing a for loop, initialization variable, start at 0. I want to start at 0 at the index. And then to know the last element, I'll be taking the advantage of vector 2 dot size function. So go all the way till vector 2 dot size, like one one value before whatever the size is. So at this point, we will be incrementing or adding I value by 1. And now all I will be doing is vector 2, like how we access an element in an array using a square brackets, we do the same thing. So here it's pretty much similar to arrays, but when declaring, we use parentheses. That's the only difference. So pretty much vector 2, whatever the I value is there, I'm assigning that value to the particular element. So as a result of this for loop, this vector is going to look like this. 9. So let's go ahead and write this part of code into the REPL. So for int I0, I less than vector 2 dot size, I plus plus, all I would be doing is vector 2 of I is I. And just to show out the elements of the vector 2 elements are, I'll be adding another for loop, the same for loop, in fact, and this time I would be printing vector 2 of I. So now if I run, you can see that I've added these elements into vector 2. So pretty much the same state as this. Now, we have seen how we create a vector, how we use for like how we use in arrays for adding elements to a vector and accessing element at a particular index, printing the value and stuff like that. Now we'll see two other methods that are there in vectors. And there can be a lot of other methods, but we majorly discuss only these 5. One of the methods is pushback. So if I write this vector here, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And remember, this is called as vector 2, and these are the indices. Okay, so push, we just have seen. This means add an element. And now where do I add the element? So the other keyword here is back. So that means whenever we want to add an element, if we are asking push back, that means element will be created here. So this block of code, like for example, if I say vector2 dot push back uh, of 10, that means there will be an additional slot created, and this is going to be 10th index, and this is going to be 10. So this is the dynamic capability of vectors. We can, on the fly, when the program is running, we can create an element, we can expand the space of vector. The advantage of vectors. So let's go ahead, push back elements 10 and 11. So what I'm doing here is that I'm simply accessing vector 2 and then push back the element. And if I want to add one more element, I'll again call pushback and I'll give a value 11. So that's the deal. That's the deal. And now, if I go ahead and print the vector size, since we added two elements, it's going to be 12. After adding two elements, vector size is 12 enough. And if I go ahead and print the vector elements at this point, you should be able to see the newly added two elements, 10 and 11. So this pretty much shows how we can expand or ask for more storage, which we cannot do with arrays when we are actually running the program. And uh, like how we added an element, for removing an element, we have something called as pop back. So push means addition, pop means remove. So, and since both of these, insertion and deletion, are happening at the end, if you want to remove an element, 2, 3, 4, 9, 10, and 11, let's say vector 2 dot push back 11. My bad. So now, for removing an element, it will always be the last element from the vector. We don't need to specify which element. We can simply say pop back. So whatever the last element is there, just get rid of it. I don't want it anymore. So that's the beauty of vector. I go like, yeah. So pop back elements. I'm calling pop back once. Notice that when I'm using pop back, I'm not passing any value. Now, as a result of pop back, if I'm calling pop back once, that means I will be element vector, which is the last element. And now if I remove one element, vector size is going to be 11. So see out after pop back and L. So if I run it while the program is running, we are controlling the way we deal with memory. At the beginning, vector 2 has 10 elements, and the 10 elements we just populated using a for loop are 0 to 9. And then we added pushback. So 10 elements and 12 elements, and the 12 elements are 0 to 11. And after we call pop back once, if you see vector size is 11 now, And these are the elements 0 to 10. So the last element, element 11, was removed from the vector. So that's the deal with pop back. If I call pop back one more time, element 10 will be removed, and it's going to say that size is 10 now. So that's how we dynamically deal with memory allocation and deallocation through vectors. And there are two other methods, which is empty and clear. So empty is like a Boolean function. This is a test to see whether I have some elements in the vector or not. It's something like, is the vector empty? So remember, I created two vectors, vec and vec2. So see out vec dot empty, and I'm doing vec dot empty on the first vector that I created. And now I'm calling the same function vec dot empty on vector 2. And now if I run them, you can see the output. Vector dot empty is one. That means the vector that we created with integers, we neither specified the size nor the elements. We said create a vector and it's empty vector and the size of it is 0. If the size of a vector is 0, then vector dot empty is true. That means it's an empty vector. If the size of the vector is not 0, then vector 2 dot empty is 0. 0 means false, 1 means true. Boolean data. Now the last one, if you want to remove all the elements, vector, we can simply do vector dot clear, clean up the vector, clean up the vector. So when you're asking to clean up the vector, you can query the vector size again, and this time you would see both of them be becoming empty vectors. So now even vector 2 is empty, and you can also query cout after calling clear function. We can also query the sizes. Yeah. You can see vector 2 dot size and vector dot size. So size is 0, empty is 1. Size is 0, empty is 1. So that's the beauty of calling the clear function. So all these 5 functions together, um, along with creating a vector, like create a vector, size of the vector, add elements to the vector, push back, remove elements from the vector. At the end, whatever the last element is, remove that, pop back. And then you have size to tell how many elements are there in a vector at a given point of time. And then you have empty to test whether a vector is empty or not. You have clear function to clear all the elements in a vector. So all of these are put together, you have vector functions. So that is pretty much all I wanted to talk in this video. This video was solely about 1D vectors, and I may do another follow-up video to walk you all through the 2D vectors part. That's all for the video, and if you have any questions, do not hesitate to reach out to me. Thank you.